Imagine a factory floor the size of a city block, buzzing with welding robots and assembly lines. In this cavernous space, workers piece together high-speed trains almost as quickly as toy cars. In China, a single plant can assemble up to 200 high-speed train sets per year, a scale unimaginable anywhere else. For decades, bullet trains were the bespoke crown jewels of nations like Japan, France, and Germany, each new model a costly, years-long project. But China has flipped the script, turning high-speed rail into a mass-produced industrial product. In the span of just 15 years, the country built the world's largest high-speed rail network and a $30 billion train manufacturing giant that churns out fleets of bullet trains at a breakneck pace. The sheer scale has left its Western rivals scrambling. China's leading train maker now eclipses Siemens and Alstom combined, forcing a global rethink of how we build for speed. Let's set the stage. High-speed rail, HSR, trains zipping at 300+ kilometers per hour, was pioneered by Japan's Shinkansen in 1964, then embraced by France's TGV and Germany's ICE in the late 20th century. These projects were prestigious and expensive, built in limited numbers. By the early 2000s, only a handful of countries had true high-speed trains, and each new line or train model was practically a national monument. In other words, HSR was an elite club. Europe and Japan dominated the technology, closely guarding their designs and know-how. Western firms like Alstom, Siemens, Bombardier, and Kawasaki Heavy Industries led the field, selling their expertise abroad sparingly and at high cost. China in the 1990s was notably absent from this club. Its rail network was large but slow and antiquated, relying on diesel locomotives and overcrowded conventional trains. But as China's economy boomed, so did its transportation needs. The early 2000s brought a realization in Beijing. To connect and modernize a nation of 1.4 billion, China needed high-speed rail, and fast. Instead of reinventing the wheel entirely, China looked abroad for a shortcut. Here's where the strategy kicks in. In 2004, China's Ministry of Railways, MOR, made foreign train makers an offer they couldn't ignore: access to the world's largest potential high-speed rail market, in exchange for their technology. This was the market for technology strategy. Western and Japanese companies could sell China their trains only if they agreed to transfer the underlying technology to Chinese partners. In essence, China said, "Help us build our own high-speed trains, and we'll buy a lot of them. Otherwise, no deal." It was a bold gambit that many had tried, and often failed, in other industries. Despite grumbles, the strategy worked. In 2004, 4 industry giants, Alstom, Siemens, Bombardier, and Kawasaki, each signed on to joint ventures with Chinese train factories. The then Railways Minister, Liu Zhijun, abruptly declared that China would buy foreign trains only if the foreign builders taught local companies how to make them. The contracts covered everything from designs and engineering blueprints to manufacturing processes. Foreign partners shipped a few finished trains to China and then set up local assembly for the rest. Chinese engineers swarmed these projects, absorbing everything. This was not a minor pilot program, it was huge. The initial deal alone was to build 200 high-speed train sets for 200 km/h service, split among the foreign suppliers. Each foreign design got a Chinese nameplate: CRH1, Bombardier's design; CRH2, Kawasaki's Shinkansen; CRH3, Siemens ICE 3, and CRH5, Alstom's Pendolino. Branded Hexi or Harmony, these trains symbolized China's approach: harmony between foreign tech and Chinese ambition. And crucially, all were assembled in China, with increasing percentages of Chinese-made components as time went on. At the start, China paid billions for these technology transfers, essentially buying an express education in high-speed rail. Some critics called it a buyer's school. China was paying tuition in the form of large contracts, and it was expensive. Siemens, for example, initially wanted 350 million yuan per train set, plus nearly 400 million euros in tech fees. They eventually lowered their price to stay in the game. But China was thinking long-term. Each joint venture was like a classroom. Chinese companies like CSR and CNR, the 2 state-owned train manufacturers at the time, learned about advanced electric motors, aerodynamic design, signaling systems, and more by building foreign-designed trains on Chinese soil. Progress came quickly. By 2007, Just 2 years into the program, Chinese engineers were already standing on their own feet. One telling case: after partnering with Japan's Kawasaki to produce the CRH-2 trains, the Chinese side, CRRC, felt confident enough to start building new variants without Japanese help. They took the basic Shinkansen design and began tweaking and upgrading it: longer train sets, higher power, new interiors. Kawasaki, alarmed, accused China of breach of contract and even intellectual property theft, but eventually backed down. The writing was on the wall. The student was becoming the master's competitor. By the late 2000s, China's approach was yielding fruit. The country was laying thousands of kilometers of new high-speed lines, and it needed faster trains to run on them. So Chinese firms applied what they'd learned to leap ahead. They launched new indigenous projects like CRH-380, a series of trains designed for 350 to 380 kilometers per hour operation, pushing beyond the original foreign tech limits. In 2010, a sleek white bullet train known as CRH-380A rolled off the production line, touted as developed in China. It promptly set a world speed record in tests, hitting 486 kilometers per hour. More importantly, it went into commercial service running at 350 kilometers per hour, slicing travel times between major cities. The student had not only caught up, it was making improvements on the original designs. Chinese engineers had learned to mix and match the best elements from each foreign partner. A German pantograph here, a Japanese bogie design there, maybe a French-inspired control system, melding them into trains optimized for China. This period also revealed China's system-level mastery. It wasn't just about train carriages. China indigenized the whole ecosystem: signaling systems, rail tracks, power supply, maintenance protocols, much of it adapted or improved for local conditions. By 2010, even before their own fully original train models arrived, Chinese companies had filed a wave of patents for tweaks to the foreign designs. These patents often only applied within China, but they signaled growing confidence. High-speed rail lines were unfurling across the nation at an unprecedented rate, creating a huge domestic market hungry for more train sets. And Chinese factories ramped up to meet that demand, often in competition with each other. All of this culminated in a defining moment for China's rail ambitions: the launch of the Beijing-Shanghai high-speed railway in 2011. This was a showcase project, a 1,318-kilometer line linking China's two biggest cities with trains running up to 300 to 350 kilometers per hour. It cost a whopping $34 billion to build. But when it opened, it cut travel time from 10 hours to about 5. And it was clear evidence that China could not only build high-speed lines at scale, but also operate them with trains as good as any in the world. By 2011, China had laid more high-speed rail than the rest of the world had in 50 years. The West's exclusive hold on high-speed rail technology had been broken. However, the story wasn't without turbulence. That same year, a tragic accident, the Wenzhou train collision, killed 40 people and raised concerns about whether China's lightning-fast expansion had compromised safety. The Railways Ministry was also rocked by a high-profile corruption scandal, with Minister Liu Zhijun, the architect of the HSR boom, fired and later jailed. In the aftermath, the government hit pause on new projects to review safety and finances. Critics pointed to mounting debts from the rail binge and labeled the project a high-speed rail leap forward, with risks. But the pause was temporary. Within a couple of years, the system regained public trust, with reforms in place, and expansion resumed, albeit at a slightly more measured pace. If anything, these growing pains only underscored how massive and crucial the HSR program had become for China. The country had committed to this path, and it wasn't turning back. By the mid-2010s, something extraordinary had happened. China was no longer just a fast follower in high-speed rail, it was a leader. The country had built the world's most extensive HSR network, by far. As of 2015, over 90 Chinese cities were linked by high-speed trains. China's HSR mileage surpassed 16,000 kilometers and kept climbing, accounting for about 2/3 of all high-speed rail tracks on Earth. And Chinese engineers were no longer content just tweaking foreign models. They rolled out brand-new train designs that were entirely Chinese. Enter the era of Fuxing, rejuvenation trains. In 2017, China unveiled the Fuxing series, the first bullet trains developed and owned outright by China, with no foreign patents holding them back. If harmony, hexi, trains symbolized joint effort with foreign partners, rejuvenation symbolized China's coming of age. These new trains, like the CR400AF and CR400BF, could cruise at 350 km per hour, and they featured the latest tech China's rail industry had to offer. They were also standardized across the country, meaning a fuxing built by one factory was virtually identical to one built by another. Standardization was key. It allowed truly mass production of trains with interchangeable parts and simplified maintenance. And it solved a big problem. Earlier, with foreign-derived models, China had been limited in exporting due to intellectual property agreements. With fuxing, those limitations evaporated. These trains were 100% Chinese IP. This moment, the launch of fuxing, is our turning point. China's high-speed rail project was no longer about catching up or learning. It was about leading and innovating on its own. On the Beijing-Shanghai line, fuxing trains started running at 350 km per hour, making them the fastest scheduled trains in the world, faster even than Japan's or Europe's regular services. It was a powerful statement. China had arrived at the forefront of high-speed rail technology, and behind that technology was a vast industrial apparatus ready to pump out trains for both domestic use and, increasingly, for export. China's high-speed rail metamorphosis sent shockwaves through the global rail industry. Practically overnight, historically speaking, China had created a domestic market so large that its manufacturers achieved unparalleled economies of scale. The numbers tell the story. CRRC, formed in 2015 by merging the big two, CSR and CNR, into one mega-company, instantly became the world's largest rolling stock manufacturer. How large? Annual revenue around $30 to $35 billion, bigger than Siemens Mobility, Alstom, and Bombardier's rail divisions combined. In fact, after the merger, CRRC alone controlled about 30% of the entire global rail market by revenue, thanks mostly to its domination of the huge Chinese market. Western competitors were rattled. In Europe, alarm bells rang loud enough that Siemens and Alstom, Germany and France's rail champions, announced a merger in 2017 to create their own Airbus of rail, capable of standing up to CRRC. This merger was later blocked by EU regulators, but the fact they attempted it speaks volumes. Their fear was clear. How do you compete with a company backed by the world's biggest rail market and the deep pockets of the Chinese state? Let's compare approaches. European and Japanese high-speed trains are often marvels of engineering, but they're essentially handcrafted in small batches. Alstom's TGV or Shinkansen models are produced in the tens or low hundreds and often customized for each client or country. Different signaling systems, carriage sizes, luxuries, etc. This bespoke approach means high unit costs and long development cycles. China did the opposite. By standardizing a few core designs, like the fuxing, to use everywhere, they streamlined manufacturing and supply chains. Chinese factories introduced lean production techniques, robotic assembly, and modular construction to build trains faster and cheaper. At CRRC's flagship plants, massive assembly halls use automated welding robots for car bodies and mechanized equipment installation lines. The process starts to resemble automobile manufacturing more than traditional train building. The result, CRRC's output dwarfs any other. A single CRRC subsidiary, say CRRC Qingdao Xifang, can crank out 1,600 high-speed rail cars a year, that's dozens of full train sets, whereas a company like Siemens might produce a few dozen high-speed cars a year for the European market. The scale difference is mind-boggling. Another consequence, cost. With mass production and government support, Chinese high-speed trains tend to undercut competitors on price. Observers noted that China's cut-price bullet trains were turning into a hot export commodity around the early 2010s. When bidding for overseas projects, CRRC could offer deals that Western firms struggled to match. For example, when Chinese companies started pitching for high-speed lines in emerging markets, Southeast Asia, Eastern Europe, Africa, they often included attractive financing from state banks and turnkey solutions at lower costs. A Chinese-built high-speed rail line has a unit cost roughly one-third lower per kilometer than comparable projects in other countries, according to World Bank research, and the trains themselves are part of that package. This doesn't mean quality is low. Chinese trains are quite advanced, but it shows how scale and state backing give China an edge. Now, Western manufacturers argue that technology and quality still set them apart. Alstom proudly notes that it's the only maker of double-decker high-speed trains, and that half of the world's high-speed train fleets incorporate Alstom, Avelia technology. Japan's Shinkansen still has an unparalleled safety record and famously precise operation. German ICE trains boast cutting-edge signaling integrations. In short, Europe and Japan say, "We build bespoke luxury performance. China builds mass-produced workhorses." There's truth in that distinction. Chinese designs were initially less flashy, focused on core functionality and cost. But the gap is closing. The latest Chinese Fuxing trains are narrowing the tech gap, adding amenities and advanced features while still being churned out at scale. And in some respects, China leaped ahead. For instance, it introduced the world's first 350 km/h high-speed freight train in 2020, something Europe hasn't done, showcasing an ability to innovate new applications for HSR. Crucially, China's dominance at home provides an innovation platform. With over 40,000 kilometers of high-speed lines and nearly 4,000 trainsets running, numbers as of mid-2020s, Chinese engineers can iterate and collect vast data on performance and wear. They operate in environments from freezing Harbin to tropical Hainan, learning and improving as they go. This scale of operation is something no other country can match, giving China a treasure trove of experience to feed back into design and production. The emergence of CRRC has also raised political and security concerns abroad. In the US, for instance, CRRC won contracts to supply metro cars to cities like Boston, Chicago, and Los Angeles, with prices far below competitors. This sparked debates about China's state-subsidized companies undercutting local industry, and even worries about hidden spy tech in rail cars. The latter, an unfounded fear, but it shows the climate. By 2020, US legislation moved to bar Chinese rail companies from some transit contracts. In Europe, as mentioned, regulators blocked the Siemens-Alstom merger, partly insisting that CRRC wasn't yet a direct threat in Europe, though many disagreed, seeing that as short-sighted. The global rail market is thus at a crossroads. Will Chinese trains become as ubiquitous overseas as Chinese smartphones or solar panels? Or will protectionism and trust issues keep them at bay in certain regions? As of now, Chinese high-speed trains have begun to venture abroad. One landmark project is Indonesia's Jakarta-Bandung high-speed line, opened in 2023, which uses Chinese-built trains and technology at 350 km/h, the first HSR in Southeast Asia. China is also building the Laos-China Railway, though at lower speed, and has been involved in Turkey's high-speed line construction, though Turkey runs mainly European trains. So far, no Chinese high-speed train sets operate in Western Europe or North America, but CRRC has been eyeing opportunities like the UK's HS2 and even Amtrak's future fleet. It's clear that the competition is heating up. China's high-speed rail story is still steaming ahead, full throttle. Domestically, the network keeps expanding into new territories, albeit at a slower pace than the frenzied 2005 to 2015 construction boom. The next targets are often geographically or geologically challenging areas, like the rugged southwest, for example, lines planned towards Tibet and Yunnan, and dense urban belts where new lines aim to boost regional integration. By 2035, China envisions around 70,000 kilometers of high-speed rail, weaving the nation even closer together, including connections to neighboring countries as part of the Belt and Road Initiative. High-speed rail is also central to China's environmental and economic goals. It's helping cut airline emissions by shifting millions of passengers from air to rail, and it stimulates development in cities it touches. Technologically, China is far from resting. One frontier is speed itself. Chinese engineers are testing next-generation train prototypes, like the CR450, aiming for commercial speeds up to 400 km/h. Another headline grabber is maglev, magnetic levitation, trains. In 2021, a prototype high-speed maglev capable of 600 km/h was unveiled in Qingdao. By mid-2025, China showcased this maglev at a World Rail Conference, pitching it as a bridge between aviation and rail. Imagine city-to-city travel at half the speed of a jet, but on the ground. That's the vision. There's also research into hyperloop-like vacuum tube trains, though that's more speculative. Moreover, China is diversifying applications of its high-speed rail tech. We mentioned the high-speed freight train, designed to move goods quickly on passenger networks at 350 kilometers per hour, potentially revolutionizing logistics for high-value or perishable goods. There's also talk of using high-speed rail tech for regional commuter networks, fast intercity trains that blur the line between high-speed and metro. CRRC, as a conglomerate, is pushing into related areas: rail digital signaling, autonomous train operation, and even overseas manufacturing joint ventures, setting up local factories in countries that buy its trains, as it did for some metro systems. Internationally, the race is on. Japan, Europe, and now even emerging players like South Korea, with its KTX trains, and Spain, Talgo, are all vying for export deals and touting their own advantages. Siemens and Alstom, for example, are supplying very high-speed trains for the new Texas Central project, if it proceeds, and for Egypt's planned HSR, eager to show that their technology is still cutting edge. But China's selling point is a complete package. They can offer to build not just trains, but entire lines: infrastructure, trains, operations, financing, often cheaper and faster. One potential future scenario: more countries might opt for the China model of high-speed rail, buying a turnkey system from CRRC and its sister construction companies, especially if Western alternatives remain more expensive or hesitant. We could see a kind of bifurcation, a Chinese standard spreading in parts of Asia, Africa, Latin America, while European/Japanese standards remain in established markets. Time will tell. Finally, a broader impact. China's mass production of high-speed rail has proven that what was once a luxury can become commonplace. It's not unlike how the Ford Model T made cars accessible 100 years ago. China is doing that for bullet trains. Already, over 2.1 billion passenger trips are made on China's high-speed trains each year, a ridership the early Shinkansen engineers could hardly fathom. This normalization of high-speed travel may raise expectations worldwide. If Chinese people can zip across a country the size of a continent quickly and cheaply, why can't others? In this way, China's example might indirectly spur other nations to invest more in their own rail systems, or risk falling behind economically. We're seeing a shift from high-speed rail as a niche prestige project to high-speed rail as essential infrastructure.